What is a buffer solution?
A buffer solution is a solution that has a tendency to resist changes in pH. Even when an acid or base is added to the solution. Buffer solutions consist of a mixture of either a weak acid and its conjugate base, or a weak base and its conjugate acid, dissolved in water. When an acid is added, the base present in the solution tends to bind to the H end from the acid, serving to buffer the change in pH and preventing the concentration of H3O end from changing very much. Similarly, when a base is added, the acid in the solution tends to neutralize the base, again serving to buffer the change in pH by preventing the concentration of H3O end from changing significantly.
What is electron capture?
Electron capture is a process that involves an electron combining with a proton to form a neutron. This decreases the atomic number of the element by 1 and leaves the atomic mass unchanged.
How did scientists determine that atoms consist of electrons, neutrons, and protons?
Originally, atoms were thought to be the smallest unit of matter. But in the late 19th century, experiments allowed scientists to finally probe inside atoms. Some of these first experiments were carried out by the British physicist J. Thomson, who discovered the electron. He noticed that the rays, actually rays of electrons, though he didn't know it at the time, were deflected by electrically charged plates and concluded that these rays must consist of charged particles that were much smaller than atoms themselves. Thomson's first graduate student, Ernest Rutherford, continued to investigate the nature of the atom. In the early 20th century, Rutherford carried out a now famous experiment, in which radioactive particles were shot through extremely thin gold foil. While some bounced off of the nuclei in different directions, most of the particles actually passed through the foil undeflected. Rutherford interpreted this as an indication that the atoms making up the foil must consist of mostly empty space. Over his career, he developed the picture of the atom as a positively charged center surrounded by electrons. And he also proposed that there must be neutral particles, neutrons, to explain the different isotopes of a given element.
So if the radiation coming from the sun more or less covers all wavelengths of visible light, why aren't plants black?
Let's start with explaining the question a bit more. You can see from the graph on the preceding page that the sun provides light in almost every wavelength. The vast majority of plants, however, appear green, which means they are absorbing blue and red light and reflecting the green light back into your eyeballs. if plants were taking in all the energy the sun is providing. They would appear black, as no light would be reflected.
What is meant by dynamic equilibrium?
Equilibrium conditions in a reversible chemical reaction are described as a dynamic equilibrium. This means that even at equilibrium the reaction has not stopped, and the forward and reverse reactions are still taking place. The bulk concentrations of reactants and products don't change. But this is just because the forward and reverse reactions are happening at equal rates. The reaction never stops, it just reaches equilibrium.
Why does putting salt on the road help to melt snow?
Like we discussed, when a solute is added to a solution, its freezing point is lowered. When salt is placed on snow, it begins to dissolve into any small amount of water on the ice with which it is in immediate contact. This lowers the freezing point of the surrounding water/ice, causing it to melt into the water. This process continues until the salt is completely dissolved.
What is a breeder reactor?
A breeder reactor is a type of nuclear reactor that is capable of generating fissile material. Material that can sustain a chain fission reaction, faster than it uses it up. This is accomplished by using the neutrons given off in the fission reaction to generate additional isotopes capable of fusion. Typically this involves the use of either thorium to generate fissile uranium or uranium to generate fissile plutonium.
Why did Robert J. Lefkowitz and Brian K. Kobilka, both United States, win the Nobel Prize for Chemistry?
For studies of protein-coupled receptors. Lefkowitz and Kobilka shared this prize for their work studying a class of receptors called G protein-coupled receptors. These play a role in how cells sense their environment, and especially in how cells respond to medicines, hormones, and other signaling molecules. Lefkowitz had been working in this area since the late 1960s, and Kobilka since the 1980s. But it wasn't until 2011 that they were able to get an image of the receptor at the exact moment that a hormone activates its signaling mechanism. The prize was awarded for their collective body of work elucidating how these receptors function.
What is a bonding orbital?
A molecular orbital that is more stable than the atomic orbitals that were combined to generate it.
Is it possible to see a single molecule?
With some of the largest single molecules, like polymers, they can actually be seen by the naked eye or through a microscope. Most molecules, however, are so small that a single isolated molecule cannot be seen with even the best microscopes. There is a physical limitation that prevents their observation with light, which has to do with the size of small molecules, lengths of ca. 0.1 to 1 nanometer, being significantly smaller than the wavelengths of visible light, 400 to 700 nanometers. Other techniques based on diffracting electrons off of molecules, measuring the force molecules exert against a very small metal tip, and other methods have been developed to image small molecules. But it's impossible to see most small molecules with light in the way that we conventionally see things.
What is resonance?
Resonance is a way that chemists represent delocalized electronic structure. Let's take that statement apart to understand what it means. Delocalized means that an electron, or a pair of electrons, is not located entirely around a single atom or bond. Take a look at the two structures of nitrogen dioxide, NO2, on the following page. The negative charge is located on one oxygen atom in one resonance structure, but can be found on the other oxygen in the second resonance structure. Notice that we said electronic structure and haven't said anything about atoms moving here. That's because they don't. Resonance only deals with electrons, and the atoms are located in the same arrangement in every resonance contributor. This is important, and makes sense if you remember that the electrons aren't moving from one resonance structure to another. These structures are needed because the actual molecule is more complicated than our simple drawing system can represent.
And the temporal lobe?
The temporal lobe is involved in hearing, memory, and language skills.
What is an active site?
Each enzyme has an area called the active site in which catalytic activity is carried out. The active site is shaped in a way that reduces the energy barrier to carrying out the chemical reaction it is meant to perform. It's important to note that, while the reactant, S, must bind at the active site initially, they must also be released after the reaction has been carried out.
How much salt, NaCl, is in the average human body?
The average adult human body contains about 250 g, or roughly half of a pound, of salt.
What is an addition polymerization reaction?
The easiest way to describe an addition polymerization reaction is that monomers are bonded together without the loss of any atoms of the monomer. There are more complicated ways to classify this type of reaction based on kinetics. But it essentially boils down to this fact.
Why do polar bears have black skin and clear fur?
There is some debate on the subject, but the combination of black skin and clear fur is probably the best for keeping the polar bear warm while not giving away its position when hunting. The black color of the skin is the best for absorbing energy from the sun. Objects that appear black don't reflect any wavelengths of light. The clear fur allows that light to get to the skin, but still looks white, so the bear can blend in with the surrounding ice and snow. A few years ago, or maybe you heard this recently because it has achieved urban legend status. A rumor you may have heard is that polar bear fur is actually like a fiber optic network for harnessing or focusing sunlight toward the bear's skin. While this would have been cool, it's unfortunately completely bogus.
What do the recycle numbers mean on plastic bottles?
These are technically called resin identification codes, RSI, and were introduced in the 1980s to make it easy to separate plastics for recycling. The numbers correspond to what kind of polymer the item is made of and have no other meaning. They are not in any sort of order based on how easy or hard it is to recycle the resins. Despite rumors you might have heard about this.
Why does my mom put salt in the water to make it boil faster?
Probably because her mom told her to. There are actually two things that are affected when you add salt to water. First, the boiling point increases. Second, the heat capacity, or how much energy it takes to raise the temperature, decreases. While you might think this would change how fast your pot of water boils, the amount of salt you would have to add to see a significant change is pretty large. The real reason you add salt to water for cooking? Flavor. Salt tastes good.
What is the Henry's law?
Equation relating the pressure of a gas to its solubility in a liquid.
What is the temperature in outer space?
There is not actually a single uniform temperature for all of outer space, it tends to be warmer. At least in a relative sense, in areas that are closer to stars or planets. On average, though, the temperature is only about 3 Kelvin, which is about minus 270 degrees Celsius. It is extremely cold in outer space, so we humans would not last long floating around in the far reaches of space. Even if we could breathe there, which we can't.
What are some of the most harmful organic pollutants toward the environment?
The EPA provides a list of 12 particularly persistent organic pollutants to watch out for. The list includes aldrin, chloridane, dichlorophenyltrichloroethane, DDT, dieldrin, endrin, heptachlor, hexachlorobenzene, Mirex, toxaphene, polychlorinated biphenyls, polychlorinated dibenzopdioxins, and polychlorinated dibenzofurans. The EPA has colloquially named this group of compounds as the Dirty Dozen.
Why do some fruits and vegetables turn brown after you cut them?
When you cut or drop an apple, potato, or other fruit, some cells leak their contents, exposing all sorts of cellular machinery to air. The key player in the browning of fruits is tyrosinase, an enzyme that is involved in the oxidation of tyrosine specifically and phenols in general. Tyrosinase plays two key roles in the production of melanin, which is a general term for all sorts of pigments found in plants and animals. So once tyrosinase leaks out of the cell, it is exposed to all the oxygen and phenols it needs to start making brown pigments.
What is a triple point?
The combination of temperature and pressure values at which solid, liquid, and gas phases of a substance are in equilibrium.
What is a Lewis structure?
Lewis structures are a simple way of depicting the electronic structure of atoms and molecules. They show us which atoms are bonded to each other in a molecule and also show how many non-bonded electrons are present in the valence electron shell of each atom. The easiest way to understand them is probably to just take a look at a few. The simplest Lewis structure is that for a single hydrogen atom, it has just one electron, and its Lewis structure looks like this. The letter H lets us know that it's a hydrogen atom, and the one dot represents its one electron. Here the two Fs let us know there are two fluorine atoms. The line connecting them shows that they are bonded with a single bond, containing 2 electrons. Each has 6 more electrons surrounding it, and these electrons are non-bonding. And finally, for a molecule with more than one bond, CH2O, this molecule is called formaldehyde. The Lewis structure shows us that the carbon is involved in a single bond, sharing 2 electrons with each hydrogen atom, and a double bond, sharing 4 electrons, with the oxygen atom. The oxygen atom also has 4 non-bonding electrons.
What is a proton?
Protons are subatomic particles that carry a positive charge. They are substantially heavier than electrons, roughly 1,836 times heavier, and carry a positive charge equal in magnitude to that carried by the electron. Protons are found in the nucleus of every atom, and the number of protons present in an atom determines its chemical properties, or, in other words, determines what element it is.
What is tribology?
Tribology is a subfield of materials science dedicated to studying the wear of materials. This may include the effects of friction on a material as well as how to better engineer surfaces or lubricate interfaces between surfaces to extend their lifetime.
What is an electron transfer reaction?
It's just what it sounds like, a reaction that involves movement of an electron from one species to another. This most often means the electron is moving between 2 different molecules, although intramolecular. One molecule, electron transfer reactions are also encountered commonly in the study of chemistry.
What is phytoremediation?
Some pollutants, such as heavy metals, are not often readily treated by bioremediation techniques. In such cases, phytoremediation may be useful. Phytoremediation relies on the introduction of certain plants that are capable of absorbing a pollutant and concentrating it in the above-ground portion of the plant, which can then be removed. The pollutant-containing plants can then be destroyed in an incinerator to concentrate the pollutants even more. Or, in some cases, the pollutants can even be recycled for additional use.
Why did Yves Chauvin, France, Robert H. Grubbs, United States, and Richard R. Schrock, United States, win the Nobel Prize for Chemistry?
for the development of the metathesis method in organic synthesis. Chauvin, Grubbs, and Schrock shared the prize for their work on a metal-catalyzed reaction that exchanges, metathesizes, carbon-carbon double bonds. Many of the double bonds that react with these catalysts are very strong. So a reaction that breaks both bonds of a double bond is impressive indeed. Chauvin was the first to propose a detailed mechanism for this catalyzed reaction. Grubbs and Schrock independently developed extremely active catalysts for this reaction using primarily molybdenum and ruthenium metal centers, respectively.
Why did Gerhard Herzberg, Canada, win the Nobel Prize for Chemistry?
For his contributions to the knowledge of electronic structure and geometry of molecules, particularly free radicals. Herzberg was a famous physicist and astrophysicist, and he was awarded the Nobel Prize in Chemistry for his great achievements in molecular spectroscopy. A particular demonstration of his skill in spectroscopy was his investigations into the role of free radicals in chemical reactions. Free radicals had long been a difficult target to study, owing to their relatively short lifetimes, on the order of millionths of a second. Herzberg's talent with spectroscopy allowed him to address this and other similarly challenging, and interesting, problems. Why did Christian B.
What is an aqueous solution?
An aqueous solution is any solution in which water is the solvent. This term is used pretty frequently in chemistry, so it's good to be familiar with it.
What are the 12 principles of green chemistry?
The 12 Principles of Green Chemistry, as originally suggested by Paul Anastas and John Warner, and explained by us, are as follows: prevention. The best way to minimize the environmental effects of chemical waste is to prevent waste from ever being generated in the first place. It's easier, and better for the environment, if we can minimize the amount of waste we need to treat, clean up, or store. Atom economy. The idea behind this principle is that chemists working on developing synthetic methodologies should generally strive to incorporate as many of the reagents as possible into the final product. This helps to prevent the generation of chemical waste and also helps to reduce the quantity of reagents that need to be produced in order to generate the ultimate target. Less hazardous chemical syntheses. Chemists are encouraged to seek out synthetic routes that avoid or minimize the use of highly toxic chemicals, in addition to trying to minimize the total quantity of waste. We also want to minimize the toxicity of the waste we generate. Designing safer chemicals in addition to minimizing the toxicity of the waste generated during a chemical synthesis. Chemists should strive to select synthetic targets that will also be low in toxicity or have minimal negative impact on the environment. Safer solvents and auxiliaries whenever possible. Chemists should seek out routes that avoid the use of large quantities of solvents, separation agents, or other chemical auxiliaries. When these cannot be avoided, they should be used in minimal quantities. And the choices that are safest for the environment should be made. Design for energy efficiency. The energy costs of synthetic methods should be considered and minimized whenever possible. This may include carrying out reactions and workup procedures at ambient temperatures and pressures. Use of renewable feedstocks, reagents and solvents should be obtained from renewable sources whenever possible. Reduce derivatives. The number of synthetic steps involving derivatization, such as protection and deprotection steps or use of blocking groups, should be minimized whenever possible. The target of this principle is also to reduce waste and to promote atom economy. Catalysis reagents that behave catalytically, and as selectively as possible, should be chosen over reagents that react stoichiometrically. Design for degradation at the end of their functional life. Chemical products should degrade to yield non-toxic products that present minimal threat to the environment. Real-time analysis for pollution prevention. Analytical techniques should support in-process monitoring so that the formation of hazardous substances can be prevented. Inherently safer chemistry for accident prevention. The use of chemicals should be carried out in a manner that minimizes the likelihood of accidents that may be damaging to the environment or to human health. This includes both the choice of chemicals used as well as the method selected for carrying out a chemical process. You may notice that the 12 principles are focused closely on the practical synthesis and use of chemical products, and thus they may need to be adapted somewhat depending on the situation, e.g., basic chemical research, large-scale industrial production, non-synthetic applications of chemistry, etc.
What is the ionization energy of an atom?
The ionization energy of an atom is the amount of energy it takes to remove an electron from the atom. The process of removing an electron leaves the atom with an extra proton relative to the number of electrons, and thus creates a positively charged ion, known as a cation. The ionization energy can be thought of as a measure of how strongly an atom holds onto its electrons. In general, ionization energies increase from left to right across a period, though there are exceptions. Due to an increasing number of protons to attract electrons in the valence shell, ionization energies decrease going down a group in the periodic table. Due to the valence electrons being farther from the nucleus, and thus more shielded from its positive charge. Note that the trends in atomic radii and ionization energy go in the Same direction larger atoms tend to have lower ionization energies.
How does non-stick cooking spray work?
It's not nearly as magical as you might think. Cooking spray is just regular vegetable oil in spray form. To get it to spray out a fine mist, an emulsifier is added. And the can needs something to act as a propellant, usually alcohol, CO2, or propane.
What is electron paramagnetic resonance spectroscopy?
Electron paramagnetic resonance, EPR, spectroscopy, also known as electron spin resonance. ESR, spectroscopy, is a method used to probe unpaired electrons in a molecule. This method is fairly similar to nuclear magnetic resonance, NMR, see the modern chemical lab. But it involves exciting electronic spin states instead of nuclear ones. One downside to this technique, relative to NMR, is that the majority of molecules do not contain unpaired electrons and thus cannot be studied using EPR. On the other hand, the lack of interfering signals from most solvents and other molecules can very often be an advantage for the same reason.
What is diffusion?
Spreading of something more widely, the movement of a substance from an area of high concentration to an area of lower concentration. The scattering of waves through a space or an object.
What is cold fusion?
A cold fusion reaction is one that takes place under ambient conditions using simple equipment. Such a fusion reaction would be extremely desirable, since it could allow for a simple and efficient means of energy production.
What is a lipid bilayer?
Lipids are important in cells as they form bilayers that protect the cells and hold them together. In a lipid bilayer, the nonpolar tails gather on the inside of the bilayer, allowing the polar ends of each lipid molecule to interact favorably with the polar, aqueous environment of the cell and its surroundings. Within a bilayer, the lipid molecules can still slide around, and can even flip from one side of the bilayer to the other. Lipid bilayers generally don't allow molecules or ions to pass readily, allowing for the buildup of concentration gradients between the cell and its surroundings. Lipid bilayers are also found elsewhere, for example. They can also form separate compartments within cells.
What is a heat of formation?
The standard heat of formation for a substance is the change in enthalpy associated with its formation of 1 mole. See History of Chemistry. Of a substance from its elements with the constituent elements in their standard states, see Analytical Chemistry.
What is distillation?
A purification technique that separates substances based on their differences in boiling points.
What is kinetic energy?
Energy of an object due to its motion.
What is a proton?
A charged subatomic particle found in the nucleus of an atom, with a charge equal and opposite to that of an electron.
What are Lewis acids and bases?
The definition of a species as a Lewis acid or a Lewis base is based on whether a species has a tendency to donate its electrons to another species or whether it tends to accept electrons from another species in a chemical reaction. Lewis acids are electron acceptors, while Lewis bases are electron donors. As you can probably guess, Lewis acids tend to react with Lewis bases, since they each have what the other one is looking for.
Why did Dorothy Crowfoot Hodgkin, United Kingdom, win the Nobel Prize for Chemistry?
For her determinations by X-ray techniques of the structures of important biochemical substances. Hodgkin used X-ray crystallography to determine the structure of penicillin, vitamin B12, and a large number of other biologically relevant molecules. As the importance of computers for processing X-ray crystallographic data was increasingly being recognized, Hodgkin was noted for her exceptional ability to process the data, and the Nobel Committee recognized that this talent likely played a vital role in her ability to achieve so much during her career.
What did Empedocles believe were the 4 basic elements?
A Greek named Empedocles, who was not from Miletus, but rather Sicily, was the first to propose the 4 basic elements. These 4 elements were earth, air, water, and fire. These elements had a much different definition from that which chemists use today, which we'll get to later. Unlike the modern definition of an element, Empedocle's understanding of an element did not require it to be a pure substance. Water, for example, was obviously not the only liquid Empedocles had ever encountered. Earth represented solids, water represented liquids, air represented gases, and fire represented heat.
What is molecular orbital theory?
Molecular orbital theory is the other main theory. The first was valence bond theory, used to explain and predict bonding properties in molecules. Molecular orbital theory describes bonding interactions by using molecular orbitals that are spread out over multiple atoms. And this allows an electron's location to be described by an orbital that bonds atoms together in a more realistic way than valence bond theory.
Can reactions take place in gas, liquid, and solid phases?
Absolutely. Bimolecular, two species, reactions taking place in the gas phase and in solutions are quite similar in that they involve random diffusion of reactant molecules until they collide, at which point a reaction may take place. For reactions involving solids, the surface of a solid is often reacting with another species that is present at the interface between the solid and a gas or liquid with which it is in contact. An example would be your car rusting to form oxides.
What is an atomic number?
Number of protons in an atom.
What is cellulose?
Cellulose, see diagram below, is linear polysaccharide poly for many and saccharide means sugar. So cellulose is a chain of sugar molecules. It's an amazing molecule, it's the most abundant organic compound on the planet because it is the main component in plant cell walls. Cellulose is highly crystalline because of the way the sugar molecules are connected and because of the fact that it's made up of a single enantiomer of glucose. Like polypropylene, highly crystalline polymers like cellulose are very strong enough to make trees stand up straight.
Why did Elias James Corey, United States, win the Nobel Prize for Chemistry?
For his development of the theory and methodology of organic synthesis. Corey was awarded the Nobel Prize for his numerous important contributions to organic synthesis, including the development of theories and methods that allow for the production of biologically active natural products. This led to many pharmaceuticals becoming commercially available, and thus had a clear impact on the general public health. His research was likely so successful because he developed the principles of a methodology known as retrosynthetic analysis, in which one starts with the structure of the target molecule and analyzes in reverse order what bonds must be broken to generate simpler structures that one can already synthesize readily.
What is a cellular organelle?
An organelle is a compartmentalized subunit with a living cell that carries out a specific function. Organelles are separated from the rest of the cell by a lipid bilayer membrane that allows it to maintain different concentrations of solutes from the rest of the cell.
What keeps an electron from crashing into the nucleus?
Opposites attract, so electrons and protons are attracted to each other, making it somewhat difficult to understand why an electron wouldn't just get as close as possible to the nucleus and crash into it. The key to answering this question has to do with the fact that electrons are very small particles, so they are governed by rules that don't apply to larger objects, as we've talked about a little already. Electrons are best thought of as clouds of negative charge surrounding the nucleus. Their properties are governed by rules that describe the cloud as a whole, rather than as a single particle. It turns out that there is something favorable about the electron being spread out, or delocalized, around the nucleus. For reasons we won't go into in detail, when the electron's cloud gets packed closer to the nucleus, the energy associated with its motion, its kinetic energy, begins to rise, which makes the situation unstable. There's a balance between the stability associated with placing the electron close to the nucleus, the favorable positive-negative charge attraction, and that associated with spreading out the electron's cloud, to keep its kinetic energy low. This prevents the electron's cloud from getting too close to the nucleus or the electron just crashing into the nucleus.
What is the rate determining step of a reaction?
In a reaction with multiple steps, the rate determining step is the slowest step. It's the step that limits the rate of formation of the final products, usually because it has the highest activation energy.
How long are chemical bonds?
Chemical bonds are typically about 2 atomic radii in length. Since they are formed from 2 atoms joined together, these distances are on the order of 10 to 10 meters.
What are the 5 environmental spheres?
In the past, environmental science focused on the health of 4 areas, or spheres, of our world. These are the hydrosphere, dealing with water, the atmosphere, dealing with the air, the geosphere, dealing with the earth, and the biosphere, dealing with living organisms. Environmental scientists have recently been increasingly recognizing a 5th sphere, the anthrosphere, which deals with the ways that humans modify the overall environment by carrying out their daily activities.
What are the valence orbitals of transition metals?
The transition metals are also referred to as the d block because their valence orbitals are the d shell. See illustration on this page. There are 5 different d orbitals. 3, dxy, dxz, and dyz, of these 5 look similar, just with different orientations in space. The 4th, dx2y2, has the same shape as the previous 3. But the loops point in along the axes as opposed to between them. Finally, the dz2 looks like a p orbital pointed along the z-axis with a ring. Technically a torus, around it.
What is a chemical bond?
A chemical bond is an attractive interaction that binds atoms together through a sharing of electron density. The simplest bonding arrangement involves just 2 electrons shared between nuclei such that each effectively has a stable octet of 8 valence electrons, or just 2 in the case of HH. When 2 atoms are sharing a total of 2 electrons between them, the atoms are referred to as singly bonded to each other. Bonds are what hold atoms together in molecules, and they are usually not easily broken. The arrangement of atoms in a molecule determines the identity of a chemical compound. The making or breaking of bonds is a chemical reaction, which converts one chemical compound into another.
What is the breakdown for fuel source usage globally?
Roughly 32.4% of the world's energy is used in the form of oil. About another 27% comes from coal sources, and another 21% from natural gas. Together, these 3 sources account for a total of over 80% of the energy sources used globally. The remaining 20% comes primarily from combustible renewables and waste. 10%, nuclear energy, 6%, and hydroelectric sources, 2%. As you can see, some of the commonly discussed green energy sources, like solar energy or energy collected by wind turbines, do not yet make significant contributions to the breakdown of energy sources commonly used on a global scale.
Why did Sir Cyril Norman Hinchelwood, United Kingdom, and Nikolai Nikolaevich Semyonov, USSR, win the Nobel Prize for Chemistry?
For their researches into the mechanism of chemical reactions. These men made numerous important discoveries regarding chemical reaction mechanisms. In particular with regard to proposing and demonstrating the importance of chain reaction mechanisms. In various instances, these two men showed that observations could be explained by invoking a chain reaction mechanism, which is a mechanism that self-propagates for several cycles before terminating. Among other examples, chain mechanisms were shown to be key to chemical reactions resulting in explosions.
What is a carbohydrate?
Organic compounds of carbon, hydrogen, and water. Typically with hydrogen and oxygen in a 2:1 ratio, respectively, these are often called sugars.
How does radioactive dating work?
Radioactive dating, also called radiometric dating, is a technique used to determine the age of a sample based on the ratio of isotopes of an element present in the sample. Using the known half-life of the isotope being studied, along with knowledge of the natural abundance of the isotopes present at the time the sample was formed, the age of the sample can be determined. To obtain an accurate age for a sample, it is required that none of the isotopes being measured have been able to escape or re-enter the sample over the course of its lifetime. Otherwise this could serve to establish a ratio of isotopic abundances that is not representative of that based purely on the half-life of the isotope whose decay is being measured.
Is mass conserved during a fission process?
Almost, but not quite. A small amount of mass is given off in the form of energy. Specifically, the relationship between the amount of energy, E, released and the amount of mass, M, that becomes energy is given by the famous relationship E equals mc2, where c is the speed of light.
What is the London dispersion force?
A weak repulsive interaction between molecules resulting from interactions of electron clouds.
What is the meniscus?
A phase boundary, which is curved due to surface tension.
How do fireworks work?
Fireworks, those that explode in the sky. Technically called pyrotechnic stars or aerial shells, have only a few essential components. Once the shell gets up in the air, the main event is fueled by aluminum metal or sometimes a mix of aluminum and magnesium metal. By themselves, these elements don't burn quickly enough in the atmosphere, and the flames they produce are just boring white. So this fuel component is mixed with another chemical that helps the aluminum burn. Technically oxidize faster. Different oxidizing compounds make different colored flames when they react. Purple, NO3, blue, CSNO3, green, BaCl2, yellow, NaNO3, or red, SrCO3. There are lots of other components of modern fireworks, like gunpowder, to help disperse these chemicals to make big shapes. But all of the chemistry is based on these simple reactions.
Okay, last sweetener question. What is corn syrup?
Corn syrup is made from cornstarch either by heating up starch in an acidic water solution, or by adding an enzyme to break down the long starch molecules into simpler sugars. Chemically it is mostly maltose, which is a disaccharide, two glucose molecules stuck together, along with a small amount of larger chains of sugar molecules, oligosaccharides. The high fructose variety is made by treating regular corn syrup with a second enzyme that converts glucose into, you guessed it, fructose.
What is an ionic bond?
Attraction between two oppositely charged ions.
Why don't oil and water mix, anyway?
The simplest way to answer this is with the phrase you probably learned in high school, like dissolves like. Water is a polar molecule, so it prefers to interact with other polar molecules. Oil, a hydrocarbon of some type, lacks polar groups and forms weak van der Waals interactions with other nonpolar molecules. This is only partially correct, and the actual situation is quite complicated. The major force at work here is the stability of the water phase due to the hydrogen bond interactions. When a molecule of a hydrocarbon is dissolved in water, some number of hydrogen bonds must be broken. This bond breaking costs energy. When oil and water don't mix, these hydrogen bonds outweigh the entropy gained by mixing the phases, so the water molecules stick together, and the oil remains separated.
What is a glass?
A glass is a non-crystalline solid. It lacks order in the solid state. In polymer chemistry, scientists are concerned with the glass transition temperature. Tg, which is the temperature at which a material changes from a hard to a rubbery state. What's neat about this transition is that the material is not changing phases, i.e., from solid to liquid, but is changing from one type of solid to another.
Why are more substituted carbocations more stable?
Great question. First, let's review what led you to this question. In the unimolecular substitution reaction we looked at, an intermediate tert-butyl cation was formed, but in the bimolecular substitution reaction, the cation, this time a methyl cation, CH3, was too high in energy. In this case the hydroxide ion directly displaced the chloride ion. Generally, the more highly substituted a carbocation is, the more stable it is. There are a number of ways to explain why this is true. The first is that carbon substituents are more electron donating than hydrogen atoms. Electrons on neighboring carbon atoms can help stabilize the cationic center. Simply put, the order of carbocation stability matches the number of carbons bonded to the cationic carbon, with higher numbers leading to greater stability.
Why did Roger D. Kornberg, United States, win the Nobel Prize for Chemistry?
For his studies of the molecular basis of eukaryotic transcription. In order for DNA to be read for the purpose of producing a protein, there are a couple of key steps that must take place. Kornberg received the prize for his work to elucidate the details surrounding the first key step, transcription. Transcription involves making a copy of the DNA, which is to be transferred outside the nucleus of the cell. Interestingly, Roger Kornberg's father, Arthur Kornberg, also received a Nobel Prize in Physiology or Medicine in 1959 for his work studying how information is transferred from one DNA molecule to another. Who would have thought that his son would go on to win a Nobel Prize for a very related piece of research?
Why did Willard Frank Libby, United States, win the Nobel Prize for Chemistry?
For his method to use carbon-14 for age determination in archaeology, geology, geophysics, and other branches of science. Libby developed a procedure that uses the relative abundance of carbon isotopes in a sample to determine how old it is. This procedure has been extremely useful to scientists from many fields and has played a major role in establishing the ordering of historical events, including the prehistory of humankind.
What is the charge of a molecule?
The overall charge of a molecule is determined by the number of protons and electrons in the whole molecule. If there are more protons than electrons, the molecule will possess an overall positive charge. If there are more electrons than protons, the molecule will similarly possess an overall negative charge. A molecule with the same number of electrons and protons is neutral and has no net charge.
So the speed of sound is faster, but why does that make your voice sound weird?
The tone is actually identical, what's different is the timbre. Specifically, the lower frequencies of your voice have less power. So your voice sounds squeaky like a duck.
What makes wine taste dry?
The dry taste certainly doesn't fall into one of the 5 basic groups. But it is known to be related to the presence of tannins.
Is caramelization the same thing as the Maillard reaction?
Caramelization is the breakdown of sugar molecules with heat. Pyrolysis, while the Maillard reaction requires amino acids, proteins. Caramelization, like the Maillard reaction, is a term for hundreds of different chemical reactions taking place at the same time.
How many types of nucleotides are found in humans?
Nucleotides are named for the nitrogenous, nitrogen-containing base incorporated into the nucleotide, and there are only 5 types of bases used: adenine, guanine, cytosine, all found in both DNA and RNA, and thymine, DNA only, or uracil, RNA only. The corresponding nucleosides are called deoxyadenosine, DNA/adenosine, RNA, deoxyguanosine. DNA/guanosine, RNA, deoxycytidine, DNA/cytidine, RNA, deoxythymidine, DNA, and uridine, RNA. All of the genetic information in our body is stored in our DNA using sequences of only these 4 nucleotides. Imagine trying to describe how to make and operate an entire machine using only 4 letters. That's just what our genetic information does.
What is the basic structure of an amino acid?
The basic structure of an amino acid is shown below. Each amino acid has an amine, NH2, group, a central carbon atom known as the alpha carbon, a side chain, denoted R, and a carboxylic acid, COOH, group. The amine groups and carboxylic acid groups of amino acids can be joined in a chain to form polymers of amino acids, known as peptides. 2 amino acids form a dipeptide, 3 form a tripeptide. And chains of 4 or more amino acids are commonly referred to as polypeptides. Long polypeptides fold into specific conformations, which is what makes up a protein.
What is the rate constant for a reaction?
The rate constant for a chemical reaction is a quantity that describes how rapidly the reaction proceeds. Rate constants can have different units, depending on how many molecules are involved in the reaction. Consider a simple reaction where a single molecule of a species A becomes a molecule of species B. The rate of the reaction will depend on the concentration of species A, denoted A, present, and the rate constant, K, for this reaction. The rate equation for this reaction would be reaction rate equals Ka. This tells us that the reaction rate depends only on the concentration of A, and that the reaction rate will increase as the concentration of A is increased. In truth, the reaction rate also depends on the temperature, pressure, and perhaps other factors as well, but these are all bundled into the rate constant, K.
How is radiation exposure quantified?
The scientific unit for radiation exposure is the sievert, SV. Though several other types of units do exist. The maximum radiation exposure that is allowable for occupational exposure in the U.S. is 50 millisieverts, MSV. For comparison, the average natural background level of exposure is roughly 3 MSV.